We purchase a variety of items from the market for our daily use like milk, salt, ghee, etc. If someone asks if the milk is pure or not, they are referring adulteration. But in science, pure has a different meaning. A pure substance consists of only a single type of particles. But most of the items we deal in our daily life are mixtures. For example, milk is a mixture of proteins, fat, and water. A pure substance consists of a single form of matter. All the constituent particles of a substance have the same chemical nature. Let us learn more about mixtures. A mixture contains different substances which are not chemically combined. Seawater is a mixture which contains salt and water. Mud is a mixture of dirt and water. We can separate salt from water, but salt or NaCl is a pure substance and cannot be separated physically. From this, we can understand that a mixture contains more than one pure substance. Depending upon the nature of substances that form a mixture, mixtures can be of two types: homogeneous mixture and heterogeneous mixture. Example of homogeneous mixture is salt and water. Salt is evenly distributed throughout the water. It is mixed well in water. Another example is air. We know that air contains a number of gases like nitrogen, oxygen, carbon dioxide, etc. But we cannot see these gases separately in air. They are mixed well with each other. That is why air is a homogeneous mixture. So, if the components of a mixture are uniformly distributed, it is called homogeneous mixture. On the other hand, in heterogeneous mixture, the components are not uniformly distributed. When we mix oil and water, it is a heterogeneous mixture as the oil is not evenly distributed in water. Salt and pepper is a heterogeneous mixture. Let's learn what is solution. Solution is a homogeneous mixture of two or more substances. That means in a solution, the substances are evenly distributed. When we hear the word solution, we think that it is a liquid like soda water or lemonade. They are solutions in which the substances are evenly distributed. Lemonade has the same taste throughout it, isn't it? But there are gaseous solutions and solid solutions. Examples of gaseous solution is air as it contains many gases. Example of solid solutions are alloys. Have you heard about alloys? Alloys are mixtures of two or more metal or one metal and a non-metal. Gold is an alloy which contains copper and gold mixed together. A solution has a solvent and a solute. Solvent dissolves the other component in it. That means solvent dissolves the solute in it. Solute is a component which is dissolved in the solvent, or solute is the component which is dissolved in the solution. Let's see what are the properties of a solution. Earlier I mentioned that solution is a homogeneous mixture, that is all the components are evenly distributed. The particles of a solution are very small and we cannot see them with our naked eyes. They might be around 1 nanometer in diameter. Can you see sugar in lemonade? No. As the sugar particles dissolved are really small in nature, we cannot see them. As the particles are very small in size, they will not scatter the beam of light passing through it. The path of light is not visible in a solution. We cannot separate the solute particles from a solution by filtration and they will not settle at the bottom. Let's do an experiment to learn about the concentration of a solution. Take 2 beakers containing 50 ml of water. Add 1 teaspoonful of copper sulphate to the first beaker and 2 spoonfuls of copper sulphate to the second beaker. Stir it well. We can observe the first one contains less amount of solute and we can call the solution as a dilute solution. The second one contains more amount of solute and it can be called a concentrated solution. That means depending upon the amount of solute present in a solution, it can be called a diluted or a concentrated solution. Have you heard about saturated and unsaturated solutions? Let us check what are they through an experiment. Take 100 ml of water in two beakers. To the first one add salt, to the second one add sugar. When we add salt and sugar, they will get dissolved in water. Add more in the beakers, then again they will get dissolved. When we keep on adding salt and sugar, a point comes when we cannot add more as they will not dissolve anymore. Then we can say that solution is saturated now. Saturated solution is a solution when no more solute can be dissolved in a solution at a given temperature. At this point, the solution has dissolved as much solute as it is capable of dissolving. And the amount of solute present in a saturated solution at this temperature is called the solubility of the solute. Solubility is the ability of a solute to dissolve in a solvent. At room temperature, that is around 20 degrees centigrade, we can dissolve around 200 grams of sugar in 100 ml of water. In other words, we can say that the solubility of sugar is 200 gram per 100 ml of water at 20 degrees centigrade. But the solubility of salt is 35.7 per 100 ml of water at 20 degrees centigrade. That means at 20 degrees centigrade, 100 ml of water can dissolve 35.7 gram of salt. Then it will be a saturated solution. Now we understood what is a saturated solution. Let's see what is unsaturated solution. If the amount of solute contained in a solution is less than the saturation level, it is called unsaturated solution. That means that solution can dissolve more amount of solute at that particular temperature. It contains less than the maximum amount of solute that can be dissolved in the solution. When we add the first spoon of sugar into water in the above experiment, that sugar gets fully dissolved and that solution can dissolve more sugar. At that time, that solution can be called an unsaturated solution. From the above experiment, we can conclude that different substances have different solubilities at the same temperature. Solubility of sugar is 200 grams per 100 ml of water in 20 degrees centigrade and salt is 35.7 gram per 100 ml of water at 20 degrees centigrade. The concentration of a solution is the amount of solute present in the given amount of solution. Concentration can be calculated in three ways. One method of calculating concentration is mass by mass percentage of a solution. That means mass of solute by mass of solution into 100. Mass of solution can be calculated by simply adding the mass of solute plus mass of solvent. Another method to calculate the concentration is mass by volume percentage of the solution. That means mass of solute by volume of solution into 100. The third way to find out concentration is volume by volume percentage of a solution. That means volume of solute is divided by volume of solution into 100. Let's solve one problem related to concentration. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. Let's find out that. Mass of solute. Here the solute is salt, that is 40 gram. Mass of solvent, that means here the solvent is water, it is 320 gram. Let's find out the mass of solution. Mass of solution is mass of solute plus mass of solvent. That means 40 gram plus 320 gram, that is 360 gram. Now let's find out the concentration of the solution. Concentration of the solution is 40 by 360 into 100 gives you 11.1 percentage. 11.1 percentage is the concentration of that particular solution. A few minutes before we learned about heterogeneous solution where the components of a solution are not evenly distributed. Suspension is a heterogeneous solution where the components of a solution are not evenly distributed. Examples are salt and pepper and sand and water. Here the solute is not dissolved in the solvent and they are suspended throughout the solvent. We can see the particles of a suspension with our naked eye as they are larger than the particles of solution. Now let's find out what are the properties of suspension. Suspension is a heterogeneous mixture, that is, the components are not evenly distributed. Particles of a suspension can be seen with our naked eye. The particles of a suspension are larger enough to scatter the beam of light passing through it and we can see the path of light. But we cannot observe the path of light in solution. The solute particles settle down when a suspension is kept undisturbed for some time. For example, sand in water is a suspension. When we mix sand in water and keep it undisturbed for some time, the sand particles settles at the bottom and we can separate it by the process of filtration. Let's see what is a colloidal solution. Here the particles of one substance is suspended in another substance. As the particle size of colloidal solution is smaller than the particle size of suspension, it looks like a homogeneous mixture but it is actually heterogeneous one. And the solute will not settle at the bottom like in suspension. Milk is a colloidal solution. The particles are smaller but they can scatter the beam of light through it. Take a solution in a beaker and another one a colloidal solution. Here, solution particles will not scatter the beam of light that pass through it. But the particles of colloidal solution scatter the beam of light and we can see the path of light. This is called the Tyndall effect. Tyndall effect is the scattering of beam by a medium that contains small suspended particles. This effect is first discovered by a scientist named John Tyndall. We can see the Tyndall effect when light passes through the dust in air. It can be observed when sunlight passes through a dense forest. In forests, the air contains tiny droplets of water and they act as colloids in air and the beam of light is scattered. Let's see what are the properties of colloids. Colloid is a heterogeneous mixture. The size of the particles are smaller than suspension. We cannot see them with our naked eyes. Colloids can scatter the beam of light passing through it. The particles in colloid will not settle down at the bottom when it is kept undisturbed. Examples of colloids are fork, cheese, sponge, etc. We cannot separate the components of a colloidal solution by filtration, but they can be separated by a method called centrifugation. A device called centrifuge is used for the purpose. The solution is kept in a test tube and it will spin at high speed inside the centrifuge and we can separate the components. Solute will settle at the bottom. The solute-like component in the colloidal solution is called the dispersed phase and the component in which the dispersed phase is suspended is known as the dispersing medium. Let's see an experiment to separate the colored components of a mixture. Take a beaker and half fill it with water. Put a watch glass on the top of the beaker. This is a watch glass. Put a few drops of ink on the watch glass. Start heating the beaker. We can observe the evaporation happens from the watch glass. We cannot heat ink as it will get decomposed or burned on heating. When we heat the ink, by keeping upon the beaker, the water from the ink will get evaporated. When all the water is evaporated, we can observe some residue on the watch glass. This is the colored residue, that is the dye which present in the ink. From this we can conclude that ink is not a pure substance as it contains water and dye. We can separate a solvent from its solute by this method of evaporation. Separation of cream from milk. We know that milk is a liquid. It contains solid particles as well. But these solid particles are very small. So when we try to filter the milk, the solid particles also pass through the filter paper and we cannot separate them. For the separation of these kinds of mixtures, we will perform centrifugation. A few minutes before we learnt about centrifugation. On centrifuging, the denser particles are forced to the bottom and the lighter particles stay at the top. Denser particles will be at the bottom and at the top, light particles will be there. We get a variety of milk from market like full fat milk, toned milk, double toned milk, etc. They contain different amounts of fat. Let's try to separate the components of full fat milk. Take full cream milk in a test tube, centrifuge for 2 minutes. When we start the centrifuge, it will spin with high speed. When an object is rotating in centrifuge, it will experience centrifugal force. Centrifugal force. Centrifugal force acts on objects which move in a circular path. It acts towards the inward direction, that means to the center. When milk is centrifuged, the cream and milk is separated. Cream floats above the milk as cream has low density compared with milk. Milk will be at the bottom. At the top will be the cream and at the bottom milk will be there. This centrifugation method is applied in a variety of fields, like it is used in laboratories for blood and urine tests. In dairies, it is used to separate butter from cream. It is used in washing machines to squeeze out water from wet clothes. Now let's see how to separate mixtures of two immiscible liquids. Immiscible liquids are those which won't mix with each other. Oil and water is example of immiscible liquid. Let's check how we can separate these kinds of mixtures. Take a separating funnel. This is a separating funnel. Now pour the mixture of oil and water. This separating funnel has a stopcock. Keep the mixture undisturbed for some time. Now we can see the separate layers of oil and water is formed. Oil will form the layer over water. Open this stopcock and pour out all the water which is at the lower layer. Close the stopcock as oil reaches this point. When oil reaches this point, stop the stopcock. Thus we can separate a mixture of kerosene oil and water. This method is also used in extraction of iron from its ore. We can use this separation method to separate the kerosene oil in water and for the extraction of iron from its ore. Separation of a mixture of salt and ammonium chloride. In the chapter Matter in Our Surroundings, we learned about sublimation. Sublimation means a substance changes directly from its solid state to gaseous state. For the separation of a mixture which consists of a sublimable component, we can use the method of sublimation. Examples of solids that sublimate are ammonium chloride, naphthalene, anthracene, etc. Let's try to separate a mixture of salt and ammonium chloride. Take a stand and china dish. Place the mixture of ammonium chloride and salt on the china dish. This is a mixture of ammonium chloride and salt. Now place an inverted glass funnel over the china dish. Put a cotton plug on the mouth of the funnel. Now heat the mixture. We can observe that something gets solidified on the walls of glass funnel. When we heat the mixture of ammonium chloride and salt, as ammonium chloride can sublimate, it changes into gaseous form. As there is cotton plug on the mouth of the funnel, here is the cotton plug, and as there is cotton plug on the mouth of the funnel, the gas cannot escape out. When this hot gas comes in contact with the comparatively cooler surface of the glass, it changes into solid form and get deposited on the walls. We can separate this from the walls. Salt will be there on the china dish. Now separation of colored dyes from black ink. The black ink contains 2 to 3 colored dyes in it. Let's try to separate the colors of black ink. Take a thin strip of filter paper, draw a line on it with a pencil approximately 3 cm above the lower edge. Put a small drop of ink from the fountain pen on the center of the line. Let it dry. Lower the filter paper into a glass or jar containing water so that the drop of ink on the paper is just above the water level, and leave it undisturbed for some time. After some time, we can see different colors on it. Like this, we can see different colors. When water rises up on the filter paper, it takes along the dye particles with it. Some dye particles dissolve in water easier than others, and they are pulled with water farther up in the filter paper. This way the colors are separated from black ink. This method of separation is called the chromatography, and this chromatography is used to separate the colors in a dye, separate pigments from natural colors, and separate drugs from blood. Chromatography is a process by which the components of a mixture can be separated. Chroma in Greek means color. This technique was first used for the separation of colors. Thus, it is known as chromatography. With chromatography, we can separate the solutes that are dissolved in a solvent. Separation of a mixture of two miscible liquids. Miscible liquids are ones that can mix together. Example of miscible liquid is acetone and water. Let's try to separate a mixture of acetone and water by using distillation process. Take a stand and place a distillation flask over it. This is distillation flask. Pour the acetone and water mixture in the distillation flask. Close it with a cork and place a thermometer. This is the thermometer. To the side outlet of distillation flask, a water condenser is connected. This one is the water condenser. There are two openings for the condenser, one for the inward supply of cold water and another for the outlet of water. Now heat the mixture. On heating, the mixture starts to boil. The boiling point of acetone is 56 degrees centigrade. Boiling point of acetone is 56 degrees centigrade, and that of water is 100 degrees centigrade. When the temperature reaches 56, the acetone starts to boil and becomes vapor. But because of the cork, this vapor cannot go out. It will pass through the side pipe on which the water condenser is connected. The acetone vapor is hot, but due to the presence of cold water around it, the vapor condenses and becomes liquid. This liquid acetone will be stored in the beaker. But we should take care of one thing, that the temperature should not exceed 56 degrees centigrade. As on reaching 100 degrees centigrade, the water will change to vapor and it will be difficult to separate the mixture. This method is called distillation. But to separate the mixture by using distillation, the boiling points of the components should have sufficient difference. Like in acetone, the boiling point is 56 degrees centigrade and that of water is 100 degrees centigrade. So sufficient difference is there between the boiling points. To separate mixtures of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin, we use another method called fractional distillation. For example, to separate the constituents of petroleum, we use fractional distillation. Acetone and benzene is a miscible mixture. Acetone and benzene. Acetone and benzene is a miscible liquid. The boiling point of acetone is 56 degrees centigrade and that of benzene is 80.1 degrees centigrade. The difference in their boiling point is only 24.1 degrees centigrade, which is less than 25. Because of this, we cannot use distillation method and let us use fractional distillation. The apparatus is same as that of distillation process. The only difference is that we connect this fractionating column to this distillation flask. Take a stand and place the distillation flask. Pour the mixture of acetone and benzene into the flask. Fix a fractionating column on the flask. This column contains glass beads in it. To the side tube of the fractionating column, connect a water condenser for the passage of cold water. Keep a beaker near to the water condenser outlet. Close the mouth of the fractionating column with a cork which is connected to a thermometer. Heat the mixture. Make sure that the temperature is constant at 56 degrees centigrade as the boiling point of acetone is 56 degrees centigrade. As 56 degrees centigrade is the boiling point of acetone, acetone becomes vapor and reaches the water condenser. When the hot vapor comes in contact with cold water, vapor condenses and becomes liquid. This liquid acetone can be collected in the beaker. At 56 degrees centigrade, a few vapors of benzene will come and these vapors will be cooled by the glass beads of fractionating column and is collected back to the flask. Like this, by using fractional distillation, we can separate the miscible liquid whose difference in boiling point is less than 25 Kelvin. Let's see how can we obtain different gases from air. Air contains a homogeneous mixture of a number of gases. Mainly air contains oxygen, carbon dioxide, nitrogen and argon, and in addition to this, air contains dust and moisture. Let us see how we can separate these gases from the mixture by using fractional distillation method. At first, air is passed through a filter. The dust and moisture is trapped in the filter. Now air, which is free from moisture and dust, is passed into a chamber where the air is compressed. In this chamber, the air is compressed by the compressor. Now the pressure of gas increases. We know that when the air is compressed, the pressure will increase. And when pressure will increase, the temperature will also increase. Now this gas is hot. This hot compressed gas is passed through a pipe into the next chamber. This is a cooling chamber in which contains a pipe for the passage of cold water. You can see the inlet and outlet for the water. When hot air comes in contact with the pipe that contains cold water, the temperature of air comes down. Air becomes cool. This cooled compressed air is then passed through a pipe to the next chamber. Here there is a separator. Here the air gets expanded. When the volume increases, we know that the pressure will come down, and as a result, the temperature comes down. Here the already cooled air is expanded and the temperature again goes down. At this cooled atmosphere, carbon dioxide solidifies as dry ice and it is separated through this outlet. The air without carbon dioxide is now passed into the expansion jet where the air is expanded again, and due to this the temperature again falls. With very lower temperature, the particles of air move slowly and the space between them decreases. As a result, air changes from its gaseous form to the liquid form. Here, the liquid air is there. The liquid air passed into a fractional distillation chamber. The boiling point of oxygen is minus 183 degrees centigrade and that of argon is minus 186 degrees centigrade and that of nitrogen is minus 196 degree centigrade. If we keep the temperature of the column around minus 184 degrees centigrade, then what happens? The argon and nitrogen will vaporize and can be collected through the outlet. This is argon outlet and this is nitrogen outlet. But as the boiling point of oxygen is not yet reached, the oxygen vapors will condense in the column and will settle down in the flask. The liquid oxygen is then collected to another container. Like this, using fractional distillation method, we can separate the components of air. Now let's see an experiment to obtain pure copper sulphate from impure sample. Copper sulphate is used as a fungicide which kills fungus, algicide which kills algae in agriculture. Let's see how we get pure copper sulphate from an impure sample. The technique used for the separation of pure copper sulphate is called crystallization. Take around 5 grams of impure copper sulphate in a china dish. Add some water to it so that the copper sulphate gets dissolved. Add some more copper sulphate and continue adding till no more copper sulphate can dissolve in water. That means now we get a saturated solution. Filter the impurities through a filter paper and now keep the solution on flames. Now we can add some more copper sulphate till no more copper sulphate can be dissolved. By heating, water gets evaporated from the solution. Then cover the solution with a filter paper and leave it undisturbed for 1 to 2 days. After 2 days, pure copper sulphate crystals are formed inside the solution. Now drain the solution and dry it with a filter paper. What we get is pure copper sulphate crystals. This crystallization method is used to purify solids. We know that we get salt from seawater. To remove impurities of salt, we use this crystallization method. This crystallization technique is used for the separation of crystals of potash alum from impure samples. Potash alum is a double salt of potassium sulfate and aluminium sulfate. Imagine now this as potash alum. Take 5 grams of alum. Alum is transparent salt-like substance used in cooking and for medicinal purposes. Now dissolve the alum in minimum amount of water. Add 2 drops of sulfuric acid to it. Then heat the solution. Filter the solution through a filter paper. Transfer the solution into another beaker and allow it to cool down. We can see the formation of crystals of alum in the solution. Drain the water and dry the crystals using filter paper. Thus, by using crystallization, we get pure alum. The children who are living in cities might be familiar with the drinking water supply to houses. Let's now check what are the processes involved in water purification system in waterworks. We know that it is essential to purify the drinking water for good health. Water is transported from a reservoir. This is reservoir, and water is transported from the reservoir to the sedimentation tank. All the solids like dirt, sand and mud settle down by keeping it undisturbed. From the sedimentation tank, water goes to the loading tank. This tank is meant to sediment the suspended impurities by adding alum. From loading tank, water goes to filtration tank. Filtration tank contains layers of filtrates like fine sand, gravel and coarse gravel. The water that gets filtered through these different layers of filter will be pure from impurities. Now the water is collected in another tank in which the water is mixed with chlorine. Chlorine is helpful in killing all the pathogens like bacteria and viruses. This chlorinated water is then supplied to houses through pipes. Let's talk about the physical and chemical changes. In the lesson Matter in Our Surroundings, we learned about some physical properties of matter like rigidity, fluidity, density, melting point and boiling point. When a matter changes from its solid state to liquid state or gaseous state, only physical properties changes. For example, in the case of water, the three states, that is ice, liquid water and water vapor, have difference in their physical properties. They have difference in their appearance, but their chemical nature remains the same. But if we take the case of oil and water, both are different in their physical as well as chemical nature. They have difference in their odors, that is smell. Oil burns in air, but water extinguishes fire. Oil and water showcase different properties as they are chemically different. During burning, substances react with each other and their chemical composition changes. The chemical change is also called chemical reaction. Let's check what are the changes that happen during the burning of a candle. You might be familiar with candle and it is made up of paraffin wax. Candle is made up of paraffin wax. We get paraffin wax by the purification of petroleum. It is a hydrocarbon, that means it contains hydrogen and carbon. When we learned about flame in 8th standard, we understood that for the burning of candle, oxygen is essential. When oxygen reacts with wax in the candle, both carbon dioxide and water vapors are formed. This carbon dioxide and water vapor escape into the air. This is the chemical change that happens during the burning of candle. Due to this continuous reaction of oxygen with wax, the amount of wax becomes less. This is the physical change. That means during burning of candle, both physical and chemical changes takes place. Another examples of chemical reactions are rusting of alumina, passing electric current through water and water breaks down into hydrogen and oxygen. Burning of paper is a chemical change. On the basis of their chemical composition, the substances can be classified into elements and compounds. Elements are the simplest substances. We cannot split or break down an element using chemical reactions. The term element was first used by a scientist named Robert Boyle. A French chemist named Laurent Lavoisier gave a proper definition to an element. That means element is the basic matter that cannot be broken down into simple substances by chemical reaction. Elements can be divided into three: metals, non-metals, and metalloids. Examples of metals are gold, silver, copper, sodium, potassium, etc. Mercury is also a metal, and you all are aware that mercury is the only metal which is liquid at room temperature. Gallium and cesium become liquid slightly above room temperature, that is at 29.85 degrees centigrade. Now let us see what are the common properties of metals. They have luster, that is, they are shiny. They are silvery gray or golden yellow in color. They are good conductors of heat and electricity, that is, metals allow heat and electricity to pass through them. They possess the property of ductility. Ductility is the property in which a metal can be drawn into wires. They possess malleability. Malleability is they can be hammered into thin sheets. They are sonorous, that is, they give out a ringing sound when they are hit with a hammer. Examples of non-metals are hydrogen, oxygen, iodine, carbon, bromine, chlorine, etc. You can see in the picture carbon fibers. Bromine is a non-metal which is liquid at room temperature. Let us see what are the properties of non-metals. They display a variety of colors. They are poor conductors of heat and electricity. They are not lustrous. They are not sonorous. They don't have the property of malleability. Metalloids are also called semi-metals. They have the properties that are in between that of metals and non-metals. Examples are boron, silicon, germanium, etc. In the picture you can see silicon wafers. Let us see the properties of metalloids. Metalloids have almost similar appearance as that of metals. Their conductivity is less than that of metals. They are brittle like non-metals, that is, they can break easily. All metalloids are solids at room temperature. There are about 118 known elements, and out of these, 94 occurring naturally on Earth. 11 elements are gases at room temperature. Let's see which are they: hydrogen, nitrogen, oxygen, fluorine, chlorine, helium, neon, argon, krypton, xenon, and radon. A compound is composed of two or more elements which are chemically combined with one another in a fixed proportion. A mixture is a material made up of two different elements which are not chemically combined. In compound, the elements are chemically combined, and in mixture, the elements are not chemically combined. When we mix and crush iron fillings and sulfur powder, we get hydrogen gas. It is a colorless, odorless gas, and it is combustible. But if we heat iron fillings and sulfur powder to red hot, we will get hydrogen sulfide gas. It is a colorless gas but has the smell of rotten eggs. In both the experiments, we used the same elements, but the results were different. When we mix iron fillings and sulfur powder, there is no chemical change, and the resultant will show the properties of its elements, and the resultant is called a mixture. But when we heat the elements together, the resultant is a compound due to the chemical changes. A compound has totally different properties compared to the combining elements. Let's see what are the differences in mixture and compounds. In mixture, when elements mix with each other, a mixture is formed and no new compound is formed. But when elements react chemically, a new compound is formed. Mixtures shows the properties of its constituents, but compound has different properties when compared to the properties of its constituents. Constituents of a mixture can be separated by physical methods, but constituents of compounds cannot be separated by physical methods, and they can be separated by chemical methods. That's it about the purity of matter. If you like this video, share it with your friends. If you have any queries, put it in the comment box. Thank you.